Okay, so thanks for having us today. So we're going to talk about modern PHP security, as was just said. So first, we are both security researchers in a French company called Synactive, so that explains our weird accent. Synactive is an IT security company which focused on offensive aspects. So we've got penetration testers, reverse engineers, and we also provide trainings sometimes. At the time, we're about 60, and we work from 4 offices in France. And so, yeah, we hope we could provide you with some valuable information today. First off, some little disclaimer. We're not here to blame PHP specifically. I mean, what we're going to talk about, for the most part, can be applied to other languages as well. And yeah, we will try to show you how to avoid introducing security issues in your applications, how to, well, be aware of the existing mitigations, how to circumvent some security features that are built in PHP, and how to harden your deployments. So this will be divided into 3 sections. So first off, some description of several classes of vulnerabilities. Then bugs that can be seen in the PHP engine, and to finish with some hardening tips. And yeah, we would be very pleased to receive any feedback that you may have at our email addresses, that are in that format. Okay, let's start with some vulnerabilities. So the first one, well, you may think of it as a thing of the past because it is SQL injection, and well, we will see that it's not really a thing of the past yet. So an SQL injection, as you probably know, happens when you've got user data that ends up directly in an SQL, that is used directly to build an SQL query, and that makes that query deviate from its intended behavior. That can result in various things such as retrieval or modifications of database records, or in the worst cases, command execution on the underlying system. So yeah, we've got like old examples like this one that in most cases should not be encountered anymore, because nowadays we use things like PDO or frameworks, frameworks or ORMs. And because we use such tools, you may think that, okay, great, then we shouldn't have problems anymore, or security problems at least anymore. Well, that is not quite the case yet, as we will now see. So one first example comes from Laravel Query Builder, and is from, well, last year. So in that Query Builder, you've got some error notation that allows you to, well, add columns when you want to select things. And, well, this supports a JSON notation, which is kind of convenient. And for instance, with that example, that would result in the SQL statement at the bottom. So, well, great, that's convenient and all, except that in that precise case, the way single quotes were escaped wasn't properly implemented. It was done as, well, this way, and it resulted in the fact that you could close the JSON extract statement and inject stuff. And yeah, so for instance, if we've got an application where users have a biography that can be in several languages, and if instead of English or German or French or whatever, you use something more fancy, well, that will result in the following and in the following. And so basically you escape your JSON extract statement and you can successfully inject into the SQL query. So this was fixed, well, when it was discovered. And the fix was basically to properly escape any single quote. And it was accompanied by a comment by the maintainer that said that you should also rely on a whitelist approach. A second examples come from Magento, which is some kind of online shop, content CMS. So it resulted from the way when you got simultaneously used from and to conditions, the whole things was processed to build the resulting SQL query. So, for instance, if we wanted to, I don't know, filter articles based on their prices, but only take those in a precise range of prices, we would use a from and a to condition. And well, we take something that doesn't really look like prices actually, but maybe something that looks a bit more offensive, we will have the following. So when our from condition will be processed, we will have something like that will occur. So first off, we'll have a query that looks like this. So our field name will be replaced by price because we're working on prices. Then our placeholder, which is a question mark, will be replaced by the intended value, which in our case it is n question mark. And okay, that's it for the processing of the from condition. Then we'll go on with the to condition. So we will add a new piece of query. And again, we will replace the field name with price, and then replace our placeholder or placeholders with the intended value. And in that case, the question mark that was in what was supposed to be the value for the from condition will be replaced as well, and that will result in this, and in a more readable way in this, and we've once again successfully injected into the query. So yeah, the takeaway here is that although sometimes preparing a query twice may seem basically innocuous or even a good thing, it's not necessarily the case. Again, this was fixed when it was discovered, and here the source code was just fixed to exclude the piece of query built from the processing of the from condition from the preparing that occurs when the to condition is prepared. So basically, that piece of query here just goes at the beginning of the statement. Some general recommendation regarding SQLIs or how to avoid them. Never use user input directly to build queries. And well, instead of that, use prepare statements along with variable binding, which will make it so that the parameters will always be considered as data instead of as SQL code. And this way, it won't be possible to, well, alter the SQL query from its intended behavior. Okay.
So, yeah, it works. I'm going to discuss another new kind of attacks that just works on PHP, which is based on Phar archives. So Phar archives are just like jar archives, but it's instead of Java, it's just for PHP. And it works with 3 different formats. So it can be based on its own format called Phar also, on tar files or zip files. So it's an optional PHP module, but if you ever use Composer to deploy some application, to deploy some dependencies, or Drush to, I don't know, pilot to Drupal instance, you need this module. So it's pretty commonly used. Yeah, it's big. It's, for instance, a tar-based Phar archive. It's made of a signature, which is optional, but you can use it to sign your archive. It's made of an alias, which contains the name of your archive. It's made of a PHP stub, which contains PHP code to open and process this archive, and some metadata. What's nice about this metadata is that it's made of, it's a serialized PHP string. So we all kind of know that deserializing arbitrary data it's not nice, it's harmful in most languages and can lead to code execution. But is there a way to reach this, this thing? Can we create a file containing an arbitrary serialized string, and can we initialize it? Yes, somebody called Sam Thomas presented a trick at Black Hat 2 years ago, and he found out that when PHP take a pass, like if you want to open a file and you give it a pass, internally it will create a stream. And this functionality will also allow you to give HTTP URLs to fetch remote resources, FTP URLs to fetch other remote resources, and also Phar, which can point to your local Phar archive, like in Java, where you can point to your local jar archive and extract just one file from this archive. And when opening a Phar archive, it will automatically unserialize the data. So these patterns are dangerous patterns, because you can, in this case, I just want to know if a given file exists. It doesn't look like ridiculously dangerous, but in fact, if I just give a Phar // a Phar archive, I can unserialize arbitrary data. So it works with every file function in PHP, even MD5 files, which doesn't look dangerous at all. So the exploitation is based on pop chains. It's a subject that was already widely discussed, so I'm going to be quite quick on it. You can find a lot of documentation about it on the internet. And the idea behind it is that when you unserialize something, you will call the method wakeup on the instance, and then the method called destruct, which are just the unserialized constructor and this destructor. The code doesn't contain any dangerous class that will do something nasty when being unserialized, so you need to rely on pop chains, on dependencies. Another French company called Ambionics, they do a lot of great publications, created a tool called PHP GCC, which contains a list of already known and working pop chains and supports the Phar archive output and polyglot files and a lot of really interesting stuff. So just to give an example of a Laravel pop chain, the Laravel code contains a class named pending broadcast, and this class, when being destructed at the end of the script or when there is no reference left to your class, will call a method called dispatch on some attribute called events. And chained with another class, which is found in the faker dependency, which allows you to just generate random data, you can see that we have this function. This function will be called when we try to call a method on a PHP instance which doesn't have this method. So when this code will be executed, and if events is a generator, it will call this function with method equals dispatch and attributes containing this data. And it will also, it's by itself called format, which will call a function we can pick. So putting this serialized object, this PHP serialized object in a Phar archive and just trying to call MD5 file on this archive will allow you to execute the command called system, which allows you to call system commands with the command ID, which will just show you in which groups and which user you are running, but you can basically call any function. It was exploitable in various softwares like PHP, BB, WordPress, so even if it was known several years ago, it was not fixed everywhere. The mitigations here are really not so easy. The best way is to just remove the wrapper, so if you can't open Phar archives, it should not happen. And if you really need Phar archives, you can still use this project from Typo3, which is another CMS, and it will just override PHP internal way of parsing and opening Phar archives to replace the PHP native serialization format by just JSON. So since you can't unserialize object with JSON, this kind of behavior won't happen. Another kind of vulnerability we sometimes see during assessments is arbitrary instantiations. It comes from the Java world and arrived in PHP. So it happens because when we use scripting languages, we often try to instantiate classes by name. For instance, I get some parameter in the URL, and I will just try to instantiate the class with this name. I often find it in routers when I want to map some parts of an address to a controller without having to do this mapping by myself, by hand in the file, and sometimes in file conversion or export features. It's not commonly exploitable, but we found some classes with interesting behaviors in the core of PHP, so we'll just quickly present it. For instance, if in some application I'm able to instantiate an arbitrary class, in this case called finfo, I will be able to print, when it will try to pass its second argument, we give it, it will print every line in the file in PHP notices, just when doing the instantiation. I don't need to be able to call any method on this instance. In the same way, we have the simple XML element, which is here to parse XML documents. And in some version of PHP and some version of libxml, which is the XML parsing library in your system, we can include external objects on files in this XML document. So it was, for instance, used by Ripstech for a Chauchefoin exploit, and just from an arbitrary instantiation, they were able to take over a whole website and get remote code execution. So it's not commonly exploitable, but when it is, you really can do nice stuff with it. And another example is SPL file object. If I'm able to print a new instance of this class, I will be able to print the first line of files. We can still use Phar or HTTP or PHP wrappers in this case, so we can allow to reach all the vulnerabilities. We can also use applications on files and classes. So it's like pop chains, exploitations, but instead of calling wake up and then destruct, you will call construct and then destruct. We are not aware of any tool like PHP GCC, but for this kind of chains, but it would be a really nice thing to do, and maybe it would ease the exploitation of this kind of issues and help to prevent them. So as often, whitelisting allowed classes is the best solution to prevent this kind of issues.
Okay, the next class of vulnerability is SSRF. So that basically occurs that when a user controls a URL that will be then called by the application as opposed by the user's computer, basically. So that can result in various things, among which retrieval of data that's not intended to be public, mostly. So it should be noted that it's not limited to HTTP URLs. This can work with various schemas or protocol. There is a blind variant to SSRF, which basically means that even if you don't see the result of it directly, it doesn't mean that, well, it had no effect whatsoever. Yep. So one kind of environment when this can be particularly useful, is in cloud environments, because for various cloud hosters, you've got some metadata that's available through link local IP address. So you've got some examples for AWS and DigitalOcean, but there are similar things for Google Cloud, for example. And because you've got this, an SSRF on such a server can result in retrieving the corresponding metadata, users data, that can result in retrieving various secrets that are, of course, not intended to be public. Another example, which I think is not very well known, is SSRF over FastCGI. So FastCGI is basically a protocol that allows, well, a web server to interact with another program. And in PHP, we've got PHP FPM, which is basically an extension that implements that protocol. And it can listen either on port 9000 or on a Unix socket. And, well, it can be used along with basically any web server that supports FastCGI. We mostly see it used with Nginx. And, well, the expected behavior is that, well, when the web server receives a request that corresponds to FastCGI, it encodes it in the, well, appropriate format, forwards it to PHP FPM, which starts a PHP worker, executes the script that's pointed by the request received, and then sends back the result to the web server. However, if we've got an SSRF on that server, it becomes possible to directly interact with this service and thus to, well, basically execute an arbitrary PHP script. And well, as if it wasn't bad enough, it can go even worse because it's possible to, well, include PHP.ini directives into the fastCGI request. And thus, if you use something nice, like for instance, auto-prevent files equals php.//input, and then use, well, put some PHP code inside the body of the request, then basically you get code execution on the server. For a nice example on that, you've got one script that was implemented in Gophers that uses the, well, Gopher wrapper, because something I didn't say is that you cannot really use any wrapper. There you need something that accepts that you send, well, basically binary data to it. So general recommendations. So here we've got two cases, sorry. If the requested resource is intended to be something internal, well, then you know what should be called. So you can rely on a whitelist approach. And for added in-depth security, you can add stuff at the network layer as well, so network segmentation. However, if the resource that will be called is rather expected to be external, you cannot use a whitelist approach because you don't know what will be called. It could be basically anything, and of course you won't have an thorough list of the possible external resources. So here, although this is generally not considered an optimal approach, you could rely on a blacklist. Blacklist. Something that you need to be careful about is that, although you may think it's enough, it is not actually enough to just resolve the host that may be present. That may be present in the URL and just issue a query afterwards, because when the URL is actually let's say called, it may be resolved again, and that second resolution may result in something different that this time may be internal. And yeah, if you're relying on a cloud hoster, just check out their documentation, because there may be some hardening tips or security tips. For instance, AWS in EC2 released something that's called IMDS v2, so Instance Metadata Service v2, that increases the security, in particular against SSRF. A last category of vulnerabilities we're going to talk about today is SSTI. So basically, that occurs when you've got, well, a templating engine, and when a user is able to put something that will be used to build a template afterwards, and so if the user data contains a template expression, it will be executed when the template is rendered. So mostly this may lead to code execution. And as I said, it requires being in a case where a templating engine is used. So in PHP, we've got things like Twig, Smarty, or Mustache, and various other ones. There was one such example in the SEO-matic plugin of Craft CMS. So Craft CMS is a CMS that uses Twig as their templating engine. And SEO-matic is a plugin intended to facilitate search engine optimization. So there was an SSTI that resulted from the way unknown craft elements were processed to build the canonical URL that corresponded to these elements. And more specifically, it was done this way, so just by relying on the path info. And in case of a 404 response, the canonical URL was reflected in the link header of the response. So for instance, if we've got something like this, where we put a Twig expression within the requested URL, as you can see, this was executed before being rendered. So, well, it got possible to do things, interesting things, I mean. And in particular, well, using some craft internals as well, and particularly the fact that your user agent could be reflected in other parts anyway, it got possible to retrieve information and, for instance, things like databases password. So you've got the whole payload here, but the important thing is that using this vulnerability, you were able to retrieve various data in the configuration, in particular databases passwords. Okay, so this was fixed here by basically modifying the way canonical URLs were built for unknown elements and, well, adding a layer of sanitization in that case. Okay, so generic recommendation regarding SSTI, when possible, as always, avoid using user data directly. When available, use sandbox environments. This is not a perfect solution, but still it can help. See if your templating engine has some hardening tips in their documentation. And when possible, prefer engines that simply do not allow code execution. So now we'll talk a bit about engine bugs.
So let's just think that I'm some kind of attacker, or maybe you paid me to find issues on your website, and I stumbled upon this file, which was in 2017, containing this code. So basically, it was just evaluating any PHP code I could give with a post request. It was a vulnerability inside PHP unit. So, okay, now let's say that I have some PHP code execution, but you try to restrict what I can do on the host. So, for instance, you used OpenBSD to block me access to several folders, and you blocked me, I'm not able to call shell exec or system to execute commands. So now what can I do as an attacker to try to bypass it? First thing to understand is that executing PHP code doesn't mean that I can execute native code. I'm just executing code inside the PHP virtual machine, which is different than executing like a C program. So the PHP engine can be seen as a kind of security boundary, preventing me from doing whatever I want. So for instance, it's blocked me access to the shell exec or system function. For instance, it blocked me access to some paths. So, how can I bypass it for the second time? We can have a lot of bugs in virtual machines and interpreters. So we can have like all the memory safety issues. So I just wait for your question, like when are we going to rewrite PHP in Rust? But even in Rust, we can still have reference counting issues, garbage collection issues leading in use after free issues, or command or parameter injection, or just logic issues. So for instance, so executing native code will allow me getting around engines boundary, virtual machine boundary, and bypass every security measures it has. So I'm going to show quickly, but you can find the slides online, 2 bugs that were found in PHP interpreter last year and were only recently patched. So for instance, this bug, this number, was in IMAP open function. This function allowed developers to access remote mailboxes over the IMAP protocol. So internally, it was using a third-party library, so they had no control on what was this library doing. So it's obsolete and was abandoned for I guess, if I remember correctly, like 10 years, but they were still using it. And it was using the binary called RSH, which is often linked to SSH to connect to the remote server. However, the name of the server was not enclosed by single quotes, and using spaces, we were able to, attackers could be able to add spaces and dashes to add options to the SSH call. Unfortunately, SSH supports a parameter called proxy command, which forces it to execute an arbitrary command before trying to connect to the server. So we could get code execution, for instance, using this kind of payloads. So we have here the IMAP open call, and it's the official syntax to use when you want to connect to a remote server and access the inbox box. So you give some random server name and just a space, a dash, to add a parameter, and then your payload that will be executed in the shell. So, okay, we have to go fast. I'm skipping this, sorry. Yeah, it's not interesting. Just to say that with some memory corruptions, you also have lot of issues, and it happens a lot. And the core development doesn't consider local code execution or local vulnerabilities you can trigger using local code execution to be security relevant. For them, only functions that are being accessed remotely are dangerous. So basically, if the attacker can execute PHP code on your server, it's game over. The engine won't prevent it to happen, and it will always be able to bypass it.
Okay, so quite quick, some hardening tips. So basically, it's safe to assume that at some point, something in your application will get compromised. And it will not necessarily be your fault, actually. It could be because you rely on third-party code, on some CMS that got any plugin that got compromised, or because even you've got legacy code that you don't know how to, well, handle really properly. Yeah, and here we'll focus on two things. So the first ones are related rather to application security, so how to avoid the exploitation of some vulnerabilities that are related to configuration, and then we'll see how, well, once you got compromised, how to limit the ability for the attacker to move around. So system configuration, if you've got a file system that's read-only, it's more difficult for an attacker to get persistence there. And well, if you store your uploads elsewhere than under the web root, for instance, well, on an external service or on a dedicated host, it will be more difficult for an attacker to have a real impact while uploading PHP files. Sorry. So yeah, you can also rely on PHP FPM and its pull mechanism, so that implements stuff like UI desperation and shroud. And you can also use systemd that provides restrictions on, for instance, service families or syscalls that can be used, and enforces mount namespaces and stuff like that. And of course, keep, well, everything you use up to date as much as possible, and yeah, every library and your engine and basically everything. Now about the engine configuration. Well, first, always configure it in your php.ini rather than directly in the code. And you can rely on various directives. So for example, you've got some that will prevent, well, Lambda user, well, a generic user, I mean, to have full error traces displayed back to them when an error occurs. Of course, still log the errors because they could be useful to you. You've got directives to limit or restrict the path that are available to the applications, basically. You can limit the functions and classes that would be callable by using disabled functions and disabled classes. And you can also limit the risks of remote file inclusions using the allow, well, by disabling, well, by using allow URLF open and allow URL include. Something that's kind of funny about it is that it won't work for SMB because an SMB resource will never be considered as remote, but rather always as a local resource. Okay, so as we showed before, this is not perfect, but well, this helps. And yeah, we've got a tool backed by section 1, that's PHP config check, that can, well, check your php.ini file. So this could be a good idea for you to integrate it into your CI and CD process. Okay.
So we have 2 minutes left, so I have to be very quick. Like Lena said, we have disabled function and disabled classes to prevent attackers to use some function or classes. But how can I do a nice list of these functions? Because I searched on Google and I wasn't able to find a good list for me as an attacker point of view. For instance, Alibaba Cloud and Xcraft and a lot of Gist and Stack Overflow, they always forgot the mail function. So why is the mail function dangerous? So we already discussed IMAP Open, but internally mails also use send mail, and it's a feature for mails, for PHP mails function to accept arbitrary parameters to pass to the sendMail binary, because mail uses sendMail internally to send emails. So it's like the IMAP open bug, but in mail, and it's a feature. It's not a bug. So you can prevent it anyway. So the only way it would be to block the function mail, which is quite useful, I guess. So to prevent this kind of issues and provide better hardening, there were some projects which is now dead, so I won't read everything. It's dead because it doesn't support PHP 7. It was called Chauchefoin. And now we have some project, I don't know how to pronounce it. I will call the awesome project name starting by a S. It's also made by French people, sorry. And it's made to kill bot classes and virtual patch all the rest. So basically it's an external and dynamic PHP extension. You can just set up very easily. It's 3 steps in your terminal. And it will allow you to perform a lot of nice things like blacklisting calls matching a given regex. For instance, I can block every call to mail with the last argument, the one which is a security feature, anti-security feature and not a bug. I can prevent every call to this mail function, but still have mail available to my contact form or stuff. I can sign serialized strings to prevent them from being modified and prevent the Phar archive issue. I can prevent the execution of writable PHP files to prevent the issues like an attacker that could have been able to upload a PHP file on my server. The file will be readable, so we won't allow it to be executed. It has really a lot of features, and I really not urge you, but advise you to install this thing and to configure it for your application. And Chauchefoin, which was not supporting PHP 7, they saw that the awesome project starting with a S was really good, so they tried to copy the features and come back, but we still don't have any line of code, so let's see how it goes.
Okay, so as a quick conclusion, what we said here doesn't mean that you should give up on PHP totally. You can still use it. It's fun, it's easy to deploy, and for most uses it's, well, still safe enough and secure enough. Yeah, so we saw that if an attacker gets PHP code execution, the engine does not offer strong enough security guarantees. So, well, your first line of defense will be to use good coding practices. And then you can rely on configuration and hardening to, well, try to prevent the initial compromise, but yeah, that won't do much more. And yeah, use Snuffle Pegasus. And yeah, of course, also rely on in-depth security. It's the way to go. It basically allows anyone to do little mistakes. And yeah, on a lighter note, someone yesterday asked on Slido, don't you think that using modern frameworks are a sufficient way to prevent the Sean attack? It was about an XSS, I think. So, well, as we've seen, using frameworks can help, but it's not a miracle solution, and they come with their own limits. Thanks for your attention.
Thank you very much, Lena and Thomas. We have a couple of questions from the audience. I'm going to ask a few of them, maybe 3 of them. We have 3 more minutes. Many of the questions go in the same direction. So people asking, is PHP still a thing? What's its future? Would you recommend it for new and big applications? How would you answer, what's the future of PHP? Where will it be in 5 years or something like that?
Like the last speaker would say, it depends. I think it's always the best question, the best answer. It depends of what you need, of what you want to do, of what your team is capable of. For instance, Facebook is still using PHP. It's not official PHP, but they use HHVM, which was custom and homemade PHP interpreter because the team knew how to use PHP, how to develop with it. So now it kind of forked, and now it's called Hack. But yeah, it's still a thing, and during the assessment we do, we still see a lot of PHP. So I would say, yeah, we find a lot of issues with PHP, but that's because we see it a lot, and we have kind of a lot of experience with this language. Mm-hmm. But everything we showed was, you can apply it to any language. Yeah. Because each language has its own pitfalls and issues. So,
YouPorn runs on PHP as well, I heard. By the way, you mentioned Craft CMS as a framework or a CMS system. The sec4dev website also runs on that one. I updated recently, I hope I'm fine.
Yeah, you should.
Okay, cool. Regarding also PHP frameworks, do you folks have a favorite PHP framework, and also maybe regarding security issues?
I was freelance before working in security, and I was using Laravel a lot. And I still like Laravel because it's like Ruby on Rails, but for PHP. It's the same structure, it's the same, kind of the same design patterns. So I really like it. And yeah, even when using framework, you just have to never forget that, yeah, escaping user inputs, using whitelist, it's always a way to go. Even if the frameworks give you nice security features, it can't cover everything you can fail in some ways.
One final question, I think that's a very interesting question. Can you give any security recommendations about dependency management in PHP, for example, regarding Composer?
Being up to date, it depends, yeah.
Can I check whether I'm up to date?
Just being up to date and just, yeah, if you really like this kind of, the recommendation of using a read-only file system, because basically nothing wrong can happen. So yeah, you can't know if some dependencies have vulnerabilities, but you can prevent vulnerabilities from affecting you too much and try to limit your own exposure to what the attacker can do.
There's a security checker also by a company called Sensio Labs, which is a French company.
Yeah.
They created a Symfony framework so that you can use to check also dependencies for known vulnerabilities.
Right? Yeah, you just give your composer.json file and they will tell you which dependency is out of date and vulnerable to some issues.
Thank you very much, Lena and Thomas.